Hello students, this is Ashish Vegadwa. Today we will learn purely resistive, purely inductive and capacitive circuit in the subject AC circuits. So let's move to the content of this subject. In this topic we will learn various definitions like resistance, inductance, capacitance. After that we will learn purely resistive circuit, purely inductive circuit and purely capacitive circuit. Let's see first element, that is resistor. Difference between resistor and resistance is that resistor is kind of element where resistance is kind of property. Property of material to oppose the flow of AC or DC current is called the resistance. Unit of resistance is ohm. Generally resistance made up of carbon material and also resistance responsible for power loss in the any circuit. Also we can connect resistor in series or parallel. Let's see our second element, that is inductor. Here inductor is kind of element where inductance is kind of property. Generally inductance is present in inductor. So let's define the inductance. So property of inductor to oppose the rise of current or fall of current is called the inductance. Generally inductance is only present in AC circuit. It will not present in DC circuit because there is no rise and no fall of current in the DC circuit. So unit of inductance is Henry. Generally inductor made up of copper material and average power loss in the inductor is always zero. Generally inductors store electromagnetic energy inside it. Let's see third element, that is capacitor. Difference between capacitor and capacitance is that capacitor is kind of element where capacitance is kind of a property. So let's define the capacitance. General property of capacitor to oppose the alternating voltage or a rise of alternating voltage or fall of alternating voltage is called the capacitance. Here you can see figure that we have connected one source in series with the capacitor. This is the positive plate of capacitor, this is the negative plate of capacitor. Unit of capacitance is Faraday. There is no power loss in the capacitance and capacitor will store electrostatic energy inside. Let's define one of the term, that is power factor. So here you can see figure that here we have shown the inductive circuit, this is the capacitive circuit and below we have shown the power triangle. So let's understand first circuit, that is inductive circuit. As per this circuit, voltage vector will start from 0 degree. After 5 degree current vector will start. So current vector will lag behind voltage vector by 5 degree. So power factor of inductive circuit is always lagging. This is the capacitive circuit. In this circuit, voltage vector will start from 0 degree. Before 5 degree current vector will start. Current vector will lead to the voltage vector. So power factor of purely capacitive circuit is always leading. So here we have shown the power triangle. On reference axis we have taken kW. On vertical we have taken kVAR and resultant of kW and kVAR is kVA. So let's define power factor from the power triangle. So ratio of actual power to the apparent power is called the power factor and generally power factor denoted as cos phi, where phi is angle between voltage vector and current vector. Let's define supply source, that is AC voltage source. Here you can see figure that one of the AC source is connected in series with the resistance. So this is the direction of current. So current will flow in both the direction. So let's define the alternating source. A source which continuously able to supply AC voltage is called the AC voltage source. And as we know that alternating current is always flowing both the direction and it will continuously vary. Let's see our first circuit, that is purely resistive circuit. So in this circuit we have connected one resistance in series with the AC voltage source. So current will flow through it. So this is the equation for current. So as per Ohm's law, equation for current is I is equal to V divided by R. And as we know that resistive circuit not having any reactance. So impedance of purely resistive circuit is Z is equal to R. And impedance is term that which oppose the flow of AC current. Where resistance is term that which oppose the flow of DC current. So this is the phasor diagram of purely resistive circuit. In this circuit, voltage vector at reference axis and current vector also at reference axis. So equation for impedance is Z at angle 0 is equal to R plus J0. So this is the waveform of purely resistive circuit. In this circuit, voltage vector will start from 0 degree. Same time current will also start from 0 degree. And as we know that both of the vector will start from 0 degree and both of the vector will become maximum on 90 degree. Also we can say that both of the vector are in phase. So phasor difference in between voltage vector and current vector is 0. So cos 0 is equal to 1. So power factor of purely resistive circuit is always unity. And as we know that there is always power loss in the purely resistive circuit. So resistance is responsible for power loss and equation for instantaneous power is product of voltage and current. Let's see second circuit, that is purely inductive circuit. In this circuit also we have connected inductor in series with the AC voltage source. So current will flow through it. If we change the current passing through inductor, then BAKMF will induce inside the inductor, and this BAKMF is always exactly opposite and equal to the supply voltage. And resistance of purely inductive circuit is always zero. So due to inductive circuit, there is an inductive reactance. And this inductive reactance is always opposed the flow of AC current. Equation for inductive reactance is XL. XL is equal to 2 pi FL, where XL is directly proportional to the frequency. If we increase the frequency, then inductive reactance will increase. So this is the equation for current. That is I is equal to V divided by XL. This is the phasor diagram of purely inductive circuit. On reference axis, we have taken supply voltage, and current vector will lag behind voltage vector by 90 degree. So equation for impedance Z at angle 90 degree is equal to 0 plus J1. So this is the waveform of purely inductive circuit. In this circuit also voltage vector will start from 0 degree, but current vector will start after 90 degree to the voltage vector. So voltage vector will become maximum on 90 degree, and current vector will become maximum around 180 degree. So phasor difference in between voltage vector and current vector is 90 degree. So cos 90 is equal to 0. So power factor of purely inductive circuit is always 0 lagging. And also we know that a purely inductor is not consuming any power. So average power in pure inductor is always 0, because product of positive half cycle and negative half cycle is always 0. Hence power consumed in the purely inductive circuit is always 0. Let's see next circuit, that is purely capacitive circuit. Here also we have connected one capacitor in series with AC voltage source. So this is the capacitor C, and this is the AC voltage source, that is V. So as we know that if we supply to the capacitor, then capacitor will store charge on it. During positive half cycle, charge will store on one plate, and during negative half cycle, charge will store on opposite plate. So there is no resistance in purely capacitive circuits. So R is equal to 0. But capacitor having capacitive reactance, which opposes the flow of alternating current. Equation for capacitive reactance is Xc is equal to 1 upon 2 pi Fc. So capacitive reactance is inversely proportional to the frequency. If we increase the frequency, then capacitive reactance will decrease. This is the equation for current, that I is equal to V divided by Xc. If we increase the value of Xc, then current will reduces. This is the phasor diagram of purely capacitive circuit. On reference axis, we have taken a voltage vector, and current vector will lead to the voltage vector by 90 degree. So this is the equation for impedance. Z is equal to minus 90 degree is equal to 0 minus J1. So let's see the waveform of purely capacitive circuit. Here you can see the waveform that on x-axis we have taken time period, and y-axis we have taken voltage and current vector. So voltage vector will start from 0 degree, and current vector will start before 90 degree to the voltage vector. So phasor difference in between voltage vector and current vector is of 90 degree. So cos 90 is equal to 0. So power factor of purely capacitive circuit is always 0 leading. And also we know that capacitor will not consume any power. Let me give you some of the question for assignment. First question is that explain purely resistive circuit. Second is that explain purely inductive circuit. And the third is that explain purely capacitive circuit. Thank you.
Subscribe now and press the bell icon. Never miss an update.